Hello, I am Professor N.B. Hulle from G.H. Raisuni Institute of Engineering and Technology. In this video, we will understand the concept of star and delta conversion. To begin with, we will start, that is delta to star conversion. Here, delta to star conversion. The given thing is a delta and we want to convert into equivalent star. Here, this dotted line indicates how will be the delta, means resistance, this R1 is in between RA and RC, these two resistances. This resistance R2, which is this, it is connected between the two. This dotted line indicates its equivalent star. Similarly, if it is a star R1, R2, R3, in that case, these dotted lines indicates its equivalent delta, which is shown here. Means we have two topics in this case, that is delta to star conversion and star to delta conversion. To begin with, we will start with the delta to star conversion. Means given thing is a delta and we want to convert this delta into its equivalent star. Now here I have made some statement here. To replace equivalent delta by star or vice versa, the resistances between respective terminals must be same to have a same performance, because if we are replacing delta by star or star by delta, the performance of the circuit should not change. That is the motto. For such case, the resistance between the terminal 1 and 2 of the delta must be same as the resistance 1 and 2 of the star, and similarly. Now here, to begin with, we will calculate the resistance between the terminals 1 and 2, resistance between the terminals 1 and 2 for the delta, and we will equate its value with the star, and we will name this equation as equation number 1. If we are doing that, this is the first case, or this is the first step. Now here in this case, 1 and 2, if we are finding the resistance between the terminals 1 and 2, this assuming the third terminal is absent. In that case here, these two resistances, that is RC and RB, will come in series, and the series combination will be parallel with the RA. This resistance for the delta will be between the terminals 1 and 2, that is RA in bracket RC plus RB or RB plus RC. This total divided by parallel combination, that is R1 into R2 divided by R1 plus R2, means here it is RA plus it is RB plus it is RC, which is equal to. Now resistance between the terminals 1 and 2 for the star, it is R1 and R2. This is R1 plus R2, because 2 are in series, this terminal is open, it will not come into the picture. And we will name this equation as equation number 1. This is the equation number 1. Similarly, if we are finding the resistances between the terminals 2 and 3 for star and delta respectively, if we are calculating between 2 and 3, this RB is in parallel with the series combination of RC and RA, this whole combination. That's why it will become RB in bracket RA plus RC divided by R1 into R2 divided by R1 plus R2, means it is RA plus RB plus RC, which is equal to, if we are going for the star, in that case between the 2 and 3 terminal resistance is R2 plus R3, because in that case R1 is not in the connection, that is open circuit, means it will be, that is R2 plus R3. This is the equation number 2. Now we have the two equations here. Now we will see the third case, that is resistance between the terminals 3 and 1. This is the third case. This is third case. Now for this case, if we are finding the resistance between the terminal 1, this is 1 and 3, in that case RC is a parallel with RA and RB combination, means it is RC is a parallel with Ra plus RB divided by the combination of all, that is RA plus RB plus RC, which is equal to. In that case, for the star connection, if I am going for the star connection, here is the terminal 1 and here is the terminal 3. If we are finding this resistance between the 1 and 3, in that case, if we are finding between 1 and 3, here I will write 1 and 3. In that case here, 1 and 3, in that case R2 will not be in series or parallel, it will be open circuit. That's why its resistance will be R1 plus it is R3. This is the equation number 3. Now here, in this case, if we have 3 equations and we have the 3 unknowns. Now what we are assuming? We are assuming that RA, RB, RC are known and we want to find out R1, R2 and R3. That is nothing but delta to star conversion. Is we have the 3 equations and 3 unknowns, and if we are solving these 3 equations simultaneously, we are able to calculate the value of R1, R2 and R3. Means we are able to calculate delta to star conversion. For that case here, in this case, we will subtract the equation number 2 from equation number 1. This is 2 minus, means we will do the mathematical operation, that is equation 1 minus equation number 2. Equation number 1 minus equation number 2. I will simplify it properly. I will simplify this equation simultaneously, means it will be RA into RB plus RA into RC. I will take the sequence. RA into RB, RA into RC divided by the same. Divided by here RA plus RB plus it is RC. Then here we are subtracting this equation. This denominator is the same. Then here I will take this term minus this whole thing. Means RA into RB, then again minus RB into RC, which is equal to, if we are subtracting these two, then R2 will cancel with R2, that is R1 plus R2 minus R2 and minus R3, means the final equation will become R1 minus it is R3. If we are simplifying further, in that case, RA into RB, this RA into RB will cancel with this RA into RB. This resultant equation will be RA into RC minus RB into RC, this total divided by RA plus RB plus it is RC, which is equal to R1 minus it is R3, and this is the equation number 4. If we have the equation number 1 minus equation number 2, then we will do the addition of the equation number 3 and 4. If we are doing this addition, then R3 will cancel out, we will get the value of R1. Means adding equation number 3 and equation number, here in this particular case 3 and 4. We are adding these two equations. Means here equation number 3 plus equation number 4. We are adding equation number 3 and equation number 4. If we are adding the equation number 3 and equation number 4, I will write first its RHS. 3 plus 4, this R1 plus R1, that will be 2R1. Then this R3 minus R3 will be 0. That is right hand side. Then what will be the left hand side of this equation? The denominator is the same. That is RA plus it is RB plus it is RC. If we have this RA plus RB plus RC, then we will find out its simplification. Now I will simplify this left hand side of the equation number 3 first. And then I will add with the numerator of the equation number 4. Now RA into RC, this is RA into RC plus RB into RC plus this value. RA into RC minus this RB into this RC, which is equal to the same value. This minus RB RC is cancelling with this minus RB RC. Means here this is RA into RC plus it is RA into RC, means it is 2 RA into RC, this total divided by this RA plus RB plus it is RC, which is equal to 2R1. This 2 is cancelling with the 2. Means here in this case we are getting the final value of the resistance R1, which is equal to RA into RC divided by, here it is RA plus it is RB plus it is RC. Means here we are able to calculate the value of the resistance R1. We are able to calculate the value of the resistance R1. I will name this equation as equation number 5. Now if it is equation number 5, then we will see how we have calculated this value. We will see how we have calculated this value. I will fold something like this. Now look at the terms carefully and then we will solve the remaining things. Now look at here how we have calculated the R1. How we have calculated the R1. R1 is this resistance. R1 is this resistance. Here this resistance is connected between these two resistances. This will be the R1. How much is this value? RA into RC divided by RA plus RB plus RC, that is addition of all. Means here in the similar way, if we are planning to calculate the other values, then other values will be something like this. Now here, how we have calculated the R1? Look at here. This R1 is RA into RC divided by RA plus here. This R1 is multiplication of these two resistors divided by summation of all. Similarly, we can write this R2 is equal to this R2. It is connected between this R2. It is connected between these two resistances. That's why its value will be RA into RB divided by summation of all. That is RA plus it is RB plus it is RC. This is the equation number 6. And finally, we have the R3. This resistance is R3. Here, this will be the R3. And this R3 is connected between the two resistances, RC and RB. This resistance will be, that is RC into RB divided by summation of all, that is RA plus RB plus it is RC. This is the equation number 7. Means here, in this case, we have the 3 equations. What are the 3 equations we have? We have this R1 is equal to, from this figure itself, here this R1 is equal to RA into RC divided by RA plus RB plus it is RC. This is the equation number 5. We have the equation number 5, 6, 7, and these 3 equations will help us to convert the given delta into its equivalent star. In the next video, I will discuss about the equations for the reverse case, that is star to delta conversions. Means here in this case the given thing is the delta parameters and we are converting this delta parameters into its equivalent star values. That's all for this particular video. Thank you.